Jai Gurudev. Good morning, dear children. Seeking the blessings of Almighty, we'll move on to session 3. In the previous sessions, we were discussing about the nutrition in plants and animals. But this session is totally different from the previous sessions. You can see a collection of electrical appliances. Can you imagine a life without all these electrical appliances? Not possible, right? You people are right. It's not possible. But do you know how they function? What is the source material required? Yes, of course. Your answer is right. And the material or the source material which they require to function is electric current. And our topic and the study today is also electric current and its effects. So we are going to learn about electric current and its effects. Our session plan today is to understand the flow of electric current, learn the construction of electric circuit, and investigate the effects of electric current. Moreover, we are also going to learn the working of electromagnet and electric bell. Before moving into electric current, we will just learn something about electricity. Electricity was discovered by Benjamin Franklin in the mid of 17th century. So he was the first scientist who discovered electricity. Only after the discovery of electricity, many other inventions happened. Electricity plays a vital role in our day-to-day life. We can never imagine a life without electricity. Electricity is also the most useful form of energy which can be easily converted into various forms of other energy such as light energy, heat energy, mechanical energy and chemical energy. Alright, we'll move on to electric current and how it flows. To know about electric current, you should know about electric charge. So what is electric charge all about? Whenever there is a flow of electrons through a conducting material, we'll call it as electric charge. So electric charge refers to the flow of electrons through a conducting material. And the flow of electric charge through a conductor is termed as a electric current. So whenever there is a flow of electrons through a conducting material, it is called as electric charge, and the flow of electric charge through a conductor is termed as electric current. Electric current flows through a circuit when there is a source of electric current. So electric charge will flow through a circuit only when there is a source of electric current. Well, we'll learn what is a circuit. So this is the circuit, children. You can see a nice picture where you have a cell, switch, connecting wires and a electric bulb. So this is a cell which has a positive terminal and a negative terminal. So this cell is a source material which is going to supply the electric current. It is connected to a switch. This is the switch. It is connected to the switch through metal wires. So one end is connected to the switch and it is going on like this, and it is connected to the bell, and the other end it is connected to the positive terminal. So the two ends of the cell are connected with wires. So this is all about a circuit. Circuit is an uninterrupted or a complete path through which electric current flows. So what is a circuit? A circuit is an uninterrupted or complete path through which electric current flows. There is no break in between. See, it is a complete path. Okay, so a circuit is an uninterrupted or complete path through which electric current flows. There are certain conditions for an electric current to flow. It requires a source material, that is the cell, conducting material, that is the metal wire, and an uninterrupted path. This circuit consists of cell, switch, wires, and bulb. These are called as the components of electric circuit or circuit elements. Well, so these are called as the circuit elements or components of circuit. Here you can see two pictures. One is closed and the other one is open. You can make a circuit using the cell, wires, switch and the bulb. You have learned all this in your grade 6. See, this is a circuit where they have connected a cell, wire with a bulb. Here the path is uninterrupted. There is no break or no disturbance. See, there is a continuity and it is a closed path. So whenever there is a closed path or a complete path, current will flow. Current will flow from the positive terminal. Okay. So this is a closed path enhancing the flow of current and the bulb glows here. Whereas in this picture, it is not a closed path. The connection is broken here. There is a break in the path. So it is interrupted. So current will not flow and this is called as a open circuit. For current to flow, we require a closed path. Right, children? So whenever you have a closed path or an uninterrupted path, current will flow. Next, we'll have a glimpse of the components of circuit or the circuit elements. A cell is a source of current. It has a positive and a negative terminal. When there are two or more cells connected, we call it as a battery. That is, the positive terminal of one cell will be connected to the negative terminal of the other. The next one is a switch. The switch is used to break or connect a circuit. Whenever the switch is in on position, it will complete the circuit and you'll have a flow of current through it. Whenever the switch is in off position, the current is broken and the circuit is broken and current stops flowing. So switch plays a major role in the circuit. Whenever it is in on position, the current will flow, and whenever it is in off position, the current will not flow. Next, you have the electric appliances. Electric appliance is a device that uses the electric current to function. You would have seen fan, bulb and so many television, so many things in your house which uses electric current to function. Next come the conducting wires. These conducting wires are very much important to make a circuit. And they are made up of metals because metals are good conductors of electricity. You know what is the meaning of conductor. A material that allows current to pass through them will be called as conductor. So metals are good conductors of electricity. So conducting wires are generally made up of metals. But copper is used extensively than any other metal. Next, we'll move on to the symbols of components. That is symbols of electric components or the circuit components. The first one is the connecting wire. A wire can be symbolically represented as a sleeping line or a horizontal line. Next comes the switch. This is the switch and this is in off position because there is an interruption here. Well, next one is a bulb. it almost looks like a inverted W and a circle around it. So this is the bulb. Next is your cell. This is the positive terminal. The longer leg is the positive terminal and the shorter leg is the negative terminal. Next one is the switch, which is in on position. Here you can see there is no interruption. So you can confirm it is in on position. And the last one is the battery, where you can see more than 2 cells. Positive leg, then comes the negative one. Again, it touches the positive terminal, negative terminal, positive and negative terminal. It goes on like this. Well, children, we'll move on to the next effect of electric current called as a heating effect. We have to do some investigation here. To observe this heating effect, you'll have to make a electric circuit using wire, switch, cell and a bulb. Now keep the switch in the off position. Okay, keep the switch in off position and observe what happens in the bulb. Definitely the bulb will be cool. It will be very cool. Now what you do is you press the switch to on position. So what happens? As per our concept, when you press the switch, the circuit gets completed and the current will flow using the source material, that is the cell. Now what happens? Allow the bulb to glow for about a minute or two. After that, you just touch and observe the bulb. Definitely the bulb will be hot. You will observe that bulb has become hot. This indicates that heat is produced on passing electric current through the bulb. Well, children, so you'll have to understand when electric current is passed through a conductor, it produces heat in the conductor and this effect is called heating effect of electric current. When current is passed through a conductor, it produces heat in the conductor and this effect is called as a heating effect of electric current. This principle is used in the electric irons, immersion heaters and geysers what we use in our house. All these devices consist of a tightly wound coil called heating element. This is made up of an alloy called nichrome, which has high resistance to electric current and withstands high temperatures. Similarly, in electric bulb, the filament is made up of tungsten, which also has high resistance. Well, we'll move on to electric fuse. Children, whenever there is excess flow of current in your house, what happens? The electrical appliances will be designed accordingly to hold only a particular amount of current. So unfortunately, if you have excess flow of electric current, it cannot manage the excess flow of electric current. So what will happen? Your device will get damaged. In order to avoid that, we can use a safety device called as the electric fuse. So this is a electric fuse, children. So this electric fuse is a safety device made up of a material with low melting point. What is that? It is made up of a material with low melting point. It is used to protect the electric current and the device in the circuit from excess current passing through them. So it will protect the electric circuit. Naturally, the device will be safeguarded. So whenever there is excess flow of electric current, what will happen? This thin wire will melt and break. See, here this is a thin wire, this is a fuse. Okay. So whenever there is excess flow of current, this will melt and it will break. See, it is broken here. So when this breaks, the circuit becomes incomplete and there will be no flow of electric current. So after that, the electrical appliance is not going to work. And so what happens? Your electrical appliance is safeguarded. So the fuse wire is made from an alloy of tin and lead. and has a low melting point. So this low melting point helps us in safeguarding our electrical appliances. It melts when more than the designated amount of current flows through the circuit. So when it melts, it will break the circuit and it will safeguard your device. Of late or nowadays, we are using MCB boards in our house. That is nothing but the miniature circuit breaker, which is used intensively in many houses to safeguard your circuits. You can see that in your house next to your meter box. Next, we'll move on to the magnetic effect of electric current. Again, here we'll perform another activity. To perform this activity, we require a cell, switch and connecting wires. Actually, this activity is to prove that there is a relationship between electricity and magnetism. Okay, so all that we require is a cell, switch, connecting wires and a magnet. So we will make a circuit like this. Okay, we are going to make a circuit like this, connecting the cell with the wires, and you have a switch. So this switch is in off position, and you are going to place this on top of a table, and next to the table circuit you are going to leave a magnet. So the magnet will always rest in the north-south direction. Okay, the magnet is always resting in the north-south direction, and you are going to leave the circuit on a table, and next to the circuit you are going to leave a magnet. What happens when you switch on or when you leave the switch in on position? What happens? The current will flow through the circuit because the circuit gets completed and there will be a flow of electric current. When the current flows, the magnet gets deflected. That is, it moves from the direction placed to another direction. There is a deflection in the magnet. When you switch off, again the magnet will come back to its original position. Well children, when we switch the current off, the compass needle comes to the resting position again. So this proves that the magnetic needle gets deflected when electric current flows through the circuit. Okay, so this proves that the magnetic needle gets deflected when electric current flows through the circuit. So here you can see a nice picture where there is a circuit. This is a switch, cell, and these are the connecting wires, and these connecting wires are wrapped around or wound around a iron nail. Okay, here this is a complete circuit. So what happens? Current flows through the circuit, and this iron nail now acts like a magnet and it attracts bell pins. It attracts bell pins. In the next picture you can see the circuit is incomplete because the switch is in off position. So what happens? The iron nail does not attract the bell pins. So whenever there is a current flow in the circuit will act like a magnet, and it is a temporary magnet. Whenever there is no current flow, it will not act like a magnet. So it is well explained here. The current carrying conductor produces the same effect as produced by the magnetic field of the magnet. This effect of current is called as a magnetic effect of electric current, and this was proved by a scientist named Oersted in 1820. Well, we'll move on to electromagnet. Electromagnet is a device that acts as a magnet when current flows through its coil. It consists of a magnetic material such as a soft iron piece and a coil of insulated copper wire tightly wound around it. The material on which the wire is wound is called as a core, and it is a temporary magnet that loses its magnetic properties when the current is withdrawn. So this is the picture of solenoid. This is the picture of solenoid. Solenoid is a cylindrical shaped coil. See, this is a cylindrical shaped coil that exhibits magnetic properties similar to that of a bar magnet when current is passed. What is a solenoid? A solenoid is a cylindrical shaped coil that exhibits magnetic properties similar to that of a bar magnet when current is pass through it, and its strength depends on the amount of current flowing through it and the number of turns present in the coil. So these are the uses of electromagnets. Electromagnets are used to lift heavy iron articles in industries. Well, they are also used to separate iron from garbage drum. This is also highly used in industries. Next comes the electrical appliances. See, you can find these the use of electromagnets in loudspeakers, telephones, electric fans, washing machines, refrigerators, and electric bulbs. Next comes the electric bell. So, in this electric bell, you can see a horseshoe shaped magnet. What is this? It is a horseshoe shaped magnet. This is the structure of a electric bell. So here on top of this horseshoe shaped magnet, you can see a thin wire coiled over it. Okay. So it is wound over the horseshoe shaped magnet and it passes to the switch. Here you have the switch and it is connected to the source material called as a cell, and the other end of the wire is connected to a screw, whereas the opposite end is connected to a metal strip. Children, here you can see a horseshoe shaped magnet and wires are connecting this horseshoe shaped magnet. How it is connecting? One end is connected to the screw. It goes to the cell, switch, and it comes here and it is wound on top of the horseshoe shaped magnet. Then the other end is connected to a metal strip, which is in turn connected to a hammer. This is the hammer. And you can see a gong here, a very big gong. So this is the structure of the electric bell. Now what happens? See, when you keep the switch in on position or when you press the switch, the circuit becomes complete. See, I have marked this with red color. See, whenever the switch is in on position, what happens? The circuit becomes complete and this screw goes and touches the magnetic metal strip. This screw goes and touches the metal strip. The metal strip which is attached to the hammer in turns goes and hit the gong. What is that? Whenever the switch is in on position, the circuit becomes complete. The circuit becomes complete. Hence, as per our concept, current flows through the circuit and what happens? This screw comes in close contact to the metal strip and this makes the hammer which is attached to the metal strip to go and hit strongly on the gong. So what happens? It produces a ringing sound. So whenever there is a complete circuit, current flows through the circuit and this hammer goes and hits the gong, producing a ringing sound. So this is the function of an electric bell. Suppose when you switch off or when the switch is in off position, the circuit becomes incomplete like this. And what happens? The metal strip goes far away from the gong. So you will not have the ringing sound. So this is all about electric bell. And this is the write-up about the electric bell, children, how it is functioning. In an electric bell, you have a horseshoe type of electromagnet and which is connected to a source of current through a switch. In addition to the electromagnet, the electric bell has an armature or a metallic gong and a screw attached to a soft iron strip. When the button is pressed, the circuit becomes complete. Current starts flowing and the electromagnet attracts the iron rod. The hammer gets attracted to the gong and strikes it to produce a ringing sound. So this is all about the electric bell. With this, we come to the end of this lesson, electric current and its effects. Children, I have given you a review zone. Kindly go through this video minimum 2-3 times to understand the concepts and try to work out the review zone or the worksheets which we provide you. Thank you, dear children.